Let's work some more problems with Pythagorean Theorem. Now I'm going to be working from the Number Power book, Geometry by McGraw-Hill. It's a great book if you're a student working on your high school diploma. I like the way that it breaks down the concepts and it gives you lots of practice of individual concepts before it starts mixing the concepts together, which is very helpful. So let's work the famous word problem, okay? So I'm not going to rewrite this. We're just going to look at it here. Number 5. In right triangle ABC, the hypotenuse, side BC, is 13 inches long. Side AB is 5 inches long. What is the length of side AC? That sounds terrible, right? But it's actually a really simple problem. And because they told us it was a right triangle, and they're talking about the hypotenuse, and they're talking about the lengths of the sides, we know that that's going to be Pythagorean's theorem. And it's so easy. Pythagorean's theorem is so easy. So remember, we want to read, we want to draw and label. We want to write our formula, plug in, and then solve. So our right triangle is called ABC. Remember, that's how we denote a triangle. So we want to draw our triangle. Just draw your right triangle. It doesn't matter what it looks like. This is for your information. It says the hypotenuse is BC. So we can just label ABC, see? And there's my right angle. The hypotenuse is BC. Well, okay, so they labeled theirs different, I guess, BC. But that doesn't even matter. It's 13 inches long. That's what's important. It says the hypotenuse is 13 inches long. So whether you call it BC or whatever, doesn't matter. 13 inches, and we know that that's labeled C because it's always labeled C. And then it says the side is 5 inches long, side AB. So 5 inches long. And we're looking for the other side. So what's confusing about that is all these letters, right? But just keep yourself straight. And if you don't even want to use the letters of the vertex of the triangle, the points of the triangle, then that's fine. Leave that off. But let's go and solve our problem. So we're going to write our formula. We've got everything labeled. So we're going to write our formula: a squared, b squared, c squared. And now it's time to plug our stuff in, plug your numbers in. So do you have a number for A? You do. It's 5. Keep your square. Do you have a number for B? You don't. Keep the letter. You have a number for C? You do. Put the number in. Now remember, don't drop your squares. And then we solve it. Now, I worked this on the previous video, so I'm not going to stop and explain. Just draw your line down the equal sign. I'm going to clean it up. 13 squared off the top of my head. 169. Then remember, I'm going to put my pencil on the variable, subtract the 25 because that's got that understood positive, and just work it out. So it's really not anything you haven't done already. How do you take the opposite of a square? You take a root, cancel. What number times itself equals 144? 12. So what's the length of whatever side they said? 12. Okay, super easy. Pythagorean theorem is super easy. All right, let's do another one. Okay, let's do number 1. A mover's ramp is placed on top of a 5-foot-high staircase. If the end of the ramp is on the floor 12 feet away, how long is the ramp? Well, they gave you a picture here, so honestly, you could just look at the picture. And if this were your test, you may not have time to actually redraw their picture, but since it's not your test, we're going to redraw it and label it. So go ahead and get your stuff out and let's draw. and label. We got 12, we got 5. We want to mark your right angle, mark your letter C. That's the first thing you do. And we were looking for the length of the ramp, so we're looking for C, question mark. We can call this A, we can call this B, doesn't matter, those are the legs. So we drew and we labeled. Now we're going to write our formula. Then we're going to plug our numbers in. Now C squared, that's the easy kind when you're looking for C, right? So you can just put all that in your calculator. So 5x squared plus 12x squared, enter, 169. We just saw that number on the previous problem. So now we're put our pencil on the variable, take the square root, cancel, bring down, and what is your value for C? 13. Easy schmeezy, lemon squeezy. Okay? Let's do one more. This one is a really weird problem, and it hangs up a lot of my students. They get kind of stuck on this problem. It says Verdine is flying a model airplane at the end of a control line. The line is 17 yards long. The plane is above a point on the ground that is 15 yards away from Verdine. If the controls are held at a height of 1.5 yards, how high is the plane off the ground? Ugh, terrible looking, right? So here's your little person, here's your right triangle, but then you have this added 1.5 yards there, which makes it a really weird looking problem. So let's go ahead and draw our picture. So I'm just going to draw my right triangle. This is my right triangle here. I'm going to look at the dotted line for my right triangle, because if you can see, when I'm looking for D, it's just the leg of a triangle, and I've got this label. If this is 15, that's 15. That 1.5, we can address that at the end of the problem. So we've got 15 at the bottom of our triangle. We've got 17 here, and this is what they're calling D right here. Well, you know, I'm not going to call it D because I know this is Pythagorean's theorem. I've got a right angle. This has got to be my hypotenuse. That's got to be C. That's got to be A. So I'm just going to call this B, and let's go solve it. So we've got it all labeled. We know what we're looking for. We write our formula. We plug our stuff in. We see immediately it's going to be one of those algebra kinds. So you have to do some algebra here. So you got to clean that up. Oh, 17 squared, 289. Then we remember this is the sign for the 225, not that. So you do the opposite of adding 225, which is subtracting 225. Come back and cancel, b squared. So 289 minus 225 is 64. Take the square root of your variable. Oops, cancel that off. And that B is 8. But wait, we're not finished. So B, or their D, is 8, but it's another 1.5 yards off the ground. Oh, that's not a problem. So if we know it's already, we solved it and got 8, and we just add our 1.5 to it, how long is it? Or how far off the ground is it? 9.5 yards. Okay? Super easy.